What's up guys, welcome back to another video. This is Rishi from Team Brute Force 19838, and today I'm going to be showing you how to implement encoders in your autonomous. So the first question is, why do you need encoders in the first place? And the reason why is because using time and speed can be inconsistent since it relies on your battery voltage. Let's say your voltage is low, it won't move the exact same distance, but encoders ensure that it will move the exact distance every single time. So let's get started. The first thing we're going to want to do is first establish some variables in our utilities class. So we go over to our utilities, and right before our hardware map, we're going to put these variables. So we're going to make a static final double counts per motor rev. And here you're going to put the counts per motor revolution of your certain motor. So let's just say it's 1000. Then you're going to have another variable called static final double drive gear reduction. And this variable is going to be equal to, if you have any gears or anything like that, you're going to put your drive gear reduction. So I'm just going to put 0.5. And then finally you're going to want to put your wheel diameter inches. And let's say this is like 3.75. So now we have our last variable called static final double, and this is the counts per inch. And the reason why we calculated this is so that instead of inputting a random amount of encoder counts, we can actually just put the number of inches that it takes for a robot to move there, making it easier to program and quicker to program. And the way encoder ticks are recorded is you would start at 0 encoder ticks, then you would go to 50, 100, and then so on. So the formula for this is going to be counts per motor rev times drive gear reduction divided by wheel diameter inches times pi, which is 3.1415. And that is going to be our formula. So now that we have this established, we can actually move on to the part of the code which is relevant. So what we're going to do is we're going to make a function public void encoder drive, and in here we're first going to put a configuration. So we're going to call it string config, and the reason why we're doing this is so that we can input a string, which is the configuration, which is whether we want to move forward, backward, left, right, to make our life easier when coding with these encoders. Then we want to put the number of inches. We'll put a timeout in case the movement takes too long. Then we have to check if the op mode is active. And finally input some telemetry. So now that we have all those essential things, what we're first going to do is we're going to want to check if our op mode is active. Then if our op mode is active, we're going to get into the first part, which is where we're going to create different variables. We're going to call this double front left inches, and we'll just set this to 0. and we'll create this for our 4 other motors. After we have this, we're also going to create a variable for speed and set this to 0. So now we're going to check the configuration. So let's say our configuration for moving forward is called F. And if it's F, we're going to want to set our front left inches to negative inches, which is the amount of inches we inputted from our function. And then we're just going to want to repeat this for our other things. And that's our configuration for moving forward. Next, we're going to check for the configuration of moving backward, and I almost forgot, this has to be a double x equals, and then we're going to want to take this, put this in here, except we're going to switch the negatives. Boom. And now we're just going to repeat for our strafe. So let's say if we want to strafe right, our config for that is going to be R. And for strafing right, the first 2 are going to be negative, and the last 2 are going to be positive. I just realized I spelled that wrong in all of them. And we're also going to have our strafe left, where we'll put the same thing, except we'll just switch these negatives out. And finally, we're going to have our rotate left. So let's just call this RL for rotate left. And to rotate left, we are going to need all of the motors set to positive, and to rotate right, we're going to need all of the motors set to negative. And we have our configurations, which is finished. So after we have all of our configurations, we can get into the actual encoder part. But before we do that, let's just address the speed. To make your life easier, let's create 3 different speeds up here. And let's call them... how about we call it public static final double drive speed, and we'll set this equal to, say, 0.5. Then we'll copy and paste this twice, and we'll put strafe speed and turn speed. And let's say we want to strafe at max power, and we want to turn at 75% power. Now that we have all this, we can set our variables to the correct speed. So our speed over here, let's say we want that to be our drive speed. So here we want it to be our strafe speed, and here we want it to be our turn speed. And the reason why we do this is so that we can just keep all our variables at the top and change them, and we don't have to come down here and manually change them. So now that we have all of those, let's actually, first thing we're going to want to do is set a target position. So let's create an integer and let's call it new front left target. And let's set this to the front left's current position. And then add this, convert this to an integer. Front left inches multiplied by our counts per inch. And all we're going to want to do is copy and paste this for our other targets. Let's continue to name this. Alright, and now that we have that done, we're going to want to actually set these target positions. Target position to our new front left target. And just to make this easier to read, how about we make this into an F, B, B. So we're going to want to set the target position to our new front left target, and we're going to want to do the same for all our other motors. So now that we have all of our targets and we've set them to our positions, we actually want to run to the positions. So we're going to set our motor, and we're going to want to set the mode to DC motor.run mode.run to position. And what it does is it sets the mode of the DC motor to run to the position, and all we have to do is just change those words. So now that we have all of our encoders running to our position, the last thing we're going to want to do is set our speed. And once again, we're going to want to do it for all of our motors. So now that we have all of our speed and our position set, our motors are going to run to our position. So let's create a while loop, which will say while front left is busy, as well as front right is busy, and back left is busy, and back right is busy. While all of these things are busy, let's put some telemetry for the driver. So let's add telemetry.add data we'll say the counts per inch equals, and we'll display that as counts per inch. Let's also add the targets and the positions. So telemetry.add data targets, and we'll set this, call it running 2, and then let's use formatting %7d and %7d, and we can use %7d to print all of our variables, and we can get the current position, and we'll call this running at 1, 2, 3, 4. So we'll get front left dot get current position, comma, front right dot get current position, and we'll change this to front right, back left, and back right. So after we've defined all of our telemetry, all that's left to do is, after we have this in the while loop, all that's left to do is update it, obviously. Don't forget to do that. Update. And the whole point of our %7ds is to use them to display these current positions or changing variables, and they'll constantly be showing as these are busy. And if you want the motion to stop when one motor gets busy, all you have to do is change these ands to ors. But essentially what it does is it will wait for all 4 of our motors to get to the position and then stop running. But if you change all of the ands to ors, it'll wait for only one of the motors to finish running to position, and then it'll stop. So it depends on what you are trying to do. But typically I would recommend using the ands. And then obviously we're going to want to set our power to 0 so that our motors will stop moving. And after we've set them off, we're going to want to turn them off of the mode run to position. So we're going to want to put our DC motor in our run mode to run using encoder. And after that, all we have to do is just change this to front right, change this to back left, and change this to back right. And now we're done. That's all we're going to have to do. We now have our beautiful encoderDrive function that will help us use encoders to drive to a certain position in inches and stop at that certain position. So now let's actually implement this in our basic autonomous. So the first thing we're going to want to do is, after we have imported our hardware map, before the wait for start, we're going to want to stop and reset all of our encoders and then run using all of our encoders. So we're going to want to say robot dot front left, where is it? Front left is over here, so robot.frontLeft.set mode DC motor.run mode, we'll set this to stop and reset encoder. And then we will do this for all of our other motors as well. And then we're going to want to turn our motors onto run using an encoder. I cannot spell. And now all we have to do is just copy and paste that. Change these. And we're done with that part. After we've successfully reset our encoders, which will stop them from going to a value way too high, we can actually start implementing our encoders. So here we have our basic autonomous of moving forward, turning right, moving backward, and strafing left. But let's say we wanted to move forward 10 inches, turn right 5 inches, move backward 2 inches, and strafe left 25 inches. So instead of using this move vertical and sleep, we can now put robot.encoderDrive. And what do we have to satisfy in our encoder drive? Let's go check. We have our configuration, inches, timeout, op mode is active, and telemetry. So let's start off by first let's put, oh, that's not the right program. Let's put our configuration, and for our configuration, we're trying to move forward here, so we're going to put F. After we have our configuration, we are next going to want to put the number of inches, which is going to be 10. Then we want to put our timeout. Usually I'll use 5 seconds for this. We're going to want to make sure that the op mode is active. And then we're going to want to input our telemetry. And even though this is quite long, all we have to do is copy and paste it down here, change it to RR, which is what we use to rotate right, and change the inches to 5. And now our robot will turn right exactly 5 inches. And we do the exact same thing over here and over here. Change this to backward 2 inches, and change this to left for L, and 25 inches. And now you have a successful program that is going to run in this exact amount of inches. Obviously this is based on your variables which you fill out over here, but using this you can now make your autonomous more consistent and more precise. Make sure to subscribe and leave a comment down below if you have any questions. Check out all of this code in our GitHub repository, which will be in the description, and I'll see you guys in the next one.